previous lecture. So we're on step 5, abstraction step 5, which is to design the programming algorithm. Design the programming algorithm. So, of course, we've gone to step 1, to step 2, step 3, and step 4. So, at this point, we want to design the algorithm. That's exactly what we did last week. Don't forget, an algorithm is the step-by-step procedure for the procedure for solving a particular problem, and it can be implemented using flowcharts or pseudocodes. And I explained to you in the last class the difference between flowcharts and pseudocodes, and of course, immediately after this we'll go into flowcharts. You take pseudocodes in some other lectures. So once you've got to this point, you understand the problem, you've gotten the inputs and the output, which is step 2. You've identified the basic things you need to implement to solve the problem, which is step 3. Then you've gotten the libraries, the functions you need to solve the problem, which is step 4. Now, at step 5, the algorithm. So the algorithm will be based on the key procedural programming concepts, such as sequencing. Of course, there's no how you implement things like sequencing, selections, iterations. Sequencing in the sense that, of course, sequencing is the step-by-step solution. What should come first? What should come after? Are you taking a decision? All of that going into sequencing. Then the selection in making decisions now, where should a particular program follow based on a particular decision. Then finally, iteration should something be done multiple times, like you need to iterate a particular process, you need to repeat it for some time till you get the desired result. All of that will be shown in your algorithm. And this algorithm will also rely on the use of variables and appropriate data structures. So all of that then forms the basic way to abstract a problem. Once you can abstract the problem to be solved, then you can then now start improving on it till you get the complex, robust solution that you are looking for. Later on in your stay in the university, you will learn more on this. There are courses you take. There are courses like data structures. There are courses like system engineering. There are courses like you take a few courses that will just improve your problem solving skills, of course, in terms of complex problems now. But for your level, understand that breaking down a complex problem into a simple compartment, abstracting it away from the complexity, is key. And that's the bedrock of solving any problem in computer science. Only in computer science, even in real life, you can apply all of these into other facets of life. Like, for example, look at people that do things like event planning. Of course, they don't just look at the whole problem. They don't do it that way. They break it down. Who's going to handle catering? Is going to handle which event decorations? No, break it down like that. Then, okay, once you know, let's start with, there'll be an event decoration, there'll be catering, there'll be ushering, all itemize out like that. Then, can I improve on the complexity? Who should handle the catering? Maybe in terms of price, in terms of distance, who should handle decorations, who should handle photograph, all of that. That's how to approach complex problems. Now, to the next thing we need to do today, which is flowcharts. So flowcharts, like I defined for you in the previous class are written with program flow from top of the page to the bottom. Each command is placed in a box of the appropriate shape, and arrows are used to direct program flow. Flowchart basically describes processes. So now, all the basic process that you will need to solve a problem. We did it today. We did it in the previous class also. Okay, but let me make reference to the previous class. I told you that just write out all the basic steps you will need. Maybe at the point of high level design, or okay, maybe not. Of course, you should have done more than the point of high level design. Anyway, you should have refined the high level design to understand the basic processes that are going to be implemented in your application. So after doing that, you can now follow through the flowchart. So let's look at some of the diagrams that are needed in making flowcharts. Excuse me, please. I think there's a mistake here. Let me just remove this. So we can go back to the class now. So I just removed when I was creating this lecture, I was trying to make the card shapes and the like, so I just need to take them out. So the first is the flow line, which is the arrow. The arrow is very important because it shows the direction of the algorithm. It shows the direction, what should be done first. Afterwards, if this is implemented, where should it go to? Don't make mistakes of not putting the arrows in the right direction or not putting the arrowheads. Some people make mistakes of not putting the arrowheads, and your audience start wondering which comes first or which comes afterwards. So please don't make the mistake of not putting the arrowheads. Then the terminal should probably have come first, but it's important to top of the arrowhead anyway. But terminals indicates the beginning of the flowchart and the end of the flowchart. Here is the terminal. So when you want to start, you have to put in the start inside there, and you have to put in the stop. Otherwise, people will ask you, so where does this algorithm start from, or where does your flowchart start from? Same thing. So it's always important to indicate the start and the end of the flowchart. Then the process. Now, the actual thing you want to do, for example, if you want to do mathematical computations, you want to do logical computation, Boolean comparisons, the main thing that would actually involve carrying out a step on the computer system should be put inside the processes. Then these decisions, that's where we have this I think this should be a rhombus, yes, and this is a rhombus. Now in this rhombus, you put decisions there, either a yes or a no. Then in the parallelogram, you use the parallelogram for making inputs and outputs. So if you're going to make an input, for example, in the problem of the Google car, the input here will have to be the origin and the destination, and of course, output also the destination, the duration, the mileage will come in here. Then this is used for making comments. If you need to make comments are very much important both in programming and in algorithm design, so that it will help you yourself if you visit the program later on, or if somebody else is reading your program. So comments are so important. Then again, so if you need to create predefined processes are indicated using rectangles with double lines on the edges. So if you want to make a call to an external process or a function that is outside of your program, then you make use of these predefined processes. Like when we were talking about stage 5 in abstraction, or stage 4, where I told you that you identify the functions and the 5 frameworks that you need to implement a particular problem problem, then this comes in handy. Then off-page connector. Off-page connectors are designated with circles, and they are used for also on-page connectors. Excuse me, not off-page connectors. On-page connectors. That's what I said. On-page connectors, if you're on the same page and you want to continue your algorithm on another section of the page, all you just need to do is put it in this circle and indicate what you want to be there. You can even put A or B or C, anything. Then where you want to continue with the algorithm, start with the circle again, then put in the exact thing you put in there, then you put it there, like A. So anybody reading the algorithm will know that A is supposed to continue at that point. Then we have off-page connectors. Now, if your algorithm or your flowchart is too big for a particular page, you can use off-page connectors. Once you put in this off-page connector, then you indicate on the next page that you're continuing, that you want to continue the flowchart from. Then anybody reading will know that your algorithm hasn't stopped, but it continues. Then other ones, like you want to make a delay, yes, you use this shape. Then this alternate process, if there is an alternate process that you want to use to implement a particular that you want to use for a process, yes, there's an alternate route. You can use this alternate process indicate shape, and this is a rectangle with round edges. Then if you want to indicate data, you can use this parallelogram with round edges. So the next one is the documents. Looks like a paper, can you see it? So this is used for a document. Then multiple documents, use this in multiple places. Then preparation, if you need to prepare a step, you use this shape. Then to display on a particular machine, you use this shape. Then for manual input, if there is a particular input that you need to do manually or data, you can use this shape. Then for manual operation, there's a manual operation that you need to carry out, you can use this shape. Just indicate it inside it. So we have an example here that shows a bank teller flowchart. So at the start, a customer arrives. So after the customer makes a request, the teller inquires after the ID. If the ID is invalid, then that's ID valid, no, you end. But if the ID is valid, then you check the balance. If okay, so there was actually an arrow here that wasn't supposed to be there, so I had to take it out. So that's why I actually paused the recording. So we asked was to check the balance. If the balance is alright, you check the policy. If the balance is not right, you reject it. And if the policy is within within the purview, then you log the transaction. Then you give the cash. If not, you reject again. Then you end the program. Of course, the algorithm. Not implemented it, so it's still an algorithm using a flowchart. So that's an example of a flowchart. So you have an assignment here based on what you have already learned in class. Create a simple abstract design for the problem of online ordering and delivery of food for students in Bowen University that you attempted in the previous assignments. Then after that, you draw a flowchart for your design. So just revisit the problem of online ordering of and delivery of food that you did in the last class. I told you guys to keep it, but you still revisit it. So that's what's happening now. Hope you see the solutions, and you can use my solution if you don't have your solution, you are not comfortable with your solution. You can use my solution to solve this problem. So for further reading, you can visit these links. So thank you so much.